The split brain problem is when you're running multiple nodes, you have your data split across multiple nodes, and you have requests coming in. You have changes being made, and those changes may go to one server because this data is determined to live on that on that primary shard. They may go to another server, and Elasticsearch has to maintain an awareness of all the nodes in the cluster in order to decide which documents, which changes go to which shards. And the split brain problem is when a request comes into Elasticsearch. How does it know which server to send that update to? But when the nodes don't have a good, healthy understanding of every node that's available, you can get into a scenario where, this node thinks that it's talking to just that node, but this node is by itself, or this node is talking to another node, or you just have these partitions within the cluster at large. And so you may get a section, you may get a symptom where you have updates going to one side of the cluster that aren't getting tracked on the other side of the cluster. And so what happens when you try to remerge that, remerge the cluster back together, and heal that kind of subdivision? So the sort of official line is that if you configure Elasticsearch well, it has sort of some built-in protections in its algorithms for keeping track of which nodes are alive and healthy in the cluster, so that at the worst case, you should at least receive an error message when you try to write to a cluster that is aware that it is not healthy. And so in a well-behaved distributed system where you are trying to prioritize the consistency of the data in the system, you should expect it to tell you when it's not able to correctly process that request. So there are some provisions in configuring Elasticsearch where you can encourage that kind of behavior. There's kind of an open question right now of how well Elasticsearch behaves under certain conditions where it's under duress, as it were. Elasticsearch has actually a very good set of documentation. They have a full page where they write up kind of known issues on these kinds of resiliency subjects. I would say, as someone who is using a certain technology, I would say that it behooves you, any operations person, even when you are outsourcing your hosting service, it does behoove you to still own your uptime, own your availability, own your consistency. And so towards that end, it is good to be aware of these problems and the potential for them. I would say it's also productive to be aware of mitigating strategies for that. I would say the people who are getting the most use out of Elasticsearch, it is very helpful to be mindful of how you are sending updates into the cluster and to be fairly aware of what is happening internally when Elasticsearch is processing some updates. It's definitely something I'd like to talk a little bit more about. Maybe if we have any clarifying questions about that. Nothing quite yet. So I'm going to continue on this a little bit. Rob, you're getting ahead of me there. Yeah, so continuing a little bit, replication actually does help in the split brain scenario because you can have Elasticsearch wait to acknowledge updates to replicas. This may be something that actually is a little bit of one of these open issues being still worked on in terms of Elasticsearch's internal kind of awareness of the cluster. I think really the best thing that you can do in any case, any scale, is to run your updates to the cluster through some sort of buffering queue. This is something that comes up again and again and again. We actually have a question that's specifically about how to best buffer updates or how to best send updates into your cluster. The customers that I've worked with, especially ones at a really large scale that really have a good experience with Elasticsearch, are ones that they move the updates out of the hot path of the user as quickly as possible. They move it out of their ORMs and put them in a queue. They put them in some sort of stream processing system, perhaps. I've seen people using queues like Kafka, for example, or stream processing systems like Storm, if you need to do, especially if you need to do some sort of meta-analysis, maybe on like a time series stream. And Kafka is particularly nice because it's a very reliable distributed queue system, and it lets you replay events in the stream from arbitrary points. So you get to control, like you get a window of things that have happened in a queue. And now you have a lot more control because you can have a process that is pulling from the queue independent of the activity happening in your app. So this is isolated from the users. Independent of Elasticsearch itself, so you can kind of react to the conditions of the cluster, and you can recover if there ever are any issues with Elasticsearch by just rolling back to an earlier point and then replaying changes that have happened in the stream. So very helpful to have kind of that middle layer, and this is just kind of my intuition of what's happened, what has worked really well for especially the large scale customers. Obviously, as a service provider, it is my hope that we are running a service that is stable enough that you're not going to experience split brains. Certainly on our end, we are going to get paged when an Elasticsearch cluster is unhealthy, and we're going to get in there and deal with it. And more to the point, we're going to be monitoring clusters proactively so that we can intervene before that becomes an issue. So, but we're human, and the only thing that is constant is change itself. So there's always a factor of being able to react.